Okay, so this session is basically we are trying to discuss the concept related to the trees. So the first topic is basically the binary tree. So the binary tree. So what do you mean by the binary tree? Let's take an example and with the help of the example, we will try to understand what is binary tree. Okay, so here it is a node with the called A and it has a left child called B. Okay, and there is a child called C. And from the A have two child, that is B and the C. From the B we have another child called D, and the another child is called as E, F, the child of C, left child, and G, the right child. Now I am telling this one as a binary tree. Why I am telling this one as a binary tree? If you consider the A basically have two childs, that is A basically have two children, that is B and the C. Okay. Now for the B, you can see there are two children, that is D and the E. Same as like that. For the C, it is F and the G. Okay. So what I'm trying to conclude this one, that is for each and every node basically contains at least two childs, at least two children. Here you can see every node basically contains two children. Okay. Now you can tell that D have no child, D, E, F and the G. So the binary tree, in the binary tree basically binary tree contains zero child, one child and the two child, but not more than that, that means if I consider this one as a binary tree, I can't tell it as a binary tree because it has a three child, so we can't tell it as a binary tree, it's strictly prohibited. Okay, so in the binary tree we basically have at most two children, but 0 is also acceptable and 1 is also acceptable. Okay, let's take some another examples. Okay, now here I have drawn it as a another tree. Okay, now you people have to tell by yourself that is it's a binary tree or not. Okay, it's a binary tree or not. So here you can see here this one, you can tell it as a binary tree or not. Yes, it's a binary tree. Why? Because you can consider this one, this node basically have two children, this one and this one, and if I consider this one, it has basically two children, this one and this one, so it's a binary tree, it's a binary tree. Okay, now let's take another example, this one. So this one, it's a binary tree or not, you please tell by yourself. So here it is also a binary tree. Why? Because here if I consider this node, it has only one child, this one. If I consider this one, it has only one child, this one. So this is a binary tree. Okay, now here you can see where you can tell it this one, that is the left side based tree, it's basically called as a live left left skewed tree, SKEWED, left skewed tree. Okay, now another drawing. Okay, you people have to tell me this one, it's a binary tree or not. Yes, it's also a binary tree because it has only one children. Okay, now let's take another example. Is this a binary tree? Is this a binary tree? No, it's not a binary tree. Why it is not a binary tree? It's strictly prohibited. Here each, yes, this one has zero, this one has a zero child, this one has zero child, it's okay. But the root node, you can tell it as a root node. In the root node you basically can see that is total three children are there, this one, two and the three, so we can't tell it as a binary tree. Okay, it's very simple. That is a binary tree is a if I am tell it as a formal definition, that is the tree of the degrees 2 called binary tree. Maximum 2 means every node may have maximum 2 child, less than 2 child also acceptable, but not more than that. So each and every node must have 0 child, either 1 child or 2 child, but not more than that. If it exceeds the number 2, then we can tell it as a binary tree. Is that clear? Now we will go to the next topic. Okay, so in the binary tree we basically have an important topic. So the important topic is basically called as a tree traversal. Okay, it's basically called as a tree traversal. Okay, What do you mean by the tree traversal? Okay, so here the word traversal is basically telling us if you have a tree, if you have a tree A, B, and the C, what does it mean by traversal? That means in which order you basically visiting the nodes. You can start it with the A, after that you can visit B, or you can visit C, or you can visit first A, then you can go to the C, then after you can go to the B. There are the several ways you can visit a tree. Okay, so we basically have three ways you can visit a tree. There are basically three ways. Okay, one is basically called as a in order, one is called as a in order. Okay, now you have another, it's called as a pre-order, it's basically called as a pre-order, and the another one is basically called as a post order, it's basically called as a post order. Okay, now what is mean by the in order, what is mean by the pre-order, what is mean by the post order? So first the in order, we try to explain, try to understand that is a in order. Okay, now if I visit the left subtree first, then if I visit the root node, then if I go to the right child, then it is called as a in order. That means in a tree, in a tree, if I visit the left child first, then a root, then the right child, then it is called as a in order traversal. Okay. Now try to understand the pre-order. Okay. Now in the pre-order, we will first visit the root, then after we will go to the left child, then we will go to the right child. Okay. Then it is called as a pre-order. Okay. That means directly first we go to the root node, then we will go to the left child, then we will go to the right child. I am numbering it as a 1 2 3. Okay, then it is called as a pre-order. Okay, now try to understand the post order. Okay, now in the post order what I am going to do, first we will try to visit the left child, then we will try to visit the right child, and then we will go to the root node, then we will go to the root node, then it is called as a post order. Very simple. We will start it with the B, then we will try to visit the C, then we try to visit the root node or A, then it is called as a post order. Okay, now try to understand one thing here, it's very important why I have told it as a in order, why I am telling it as a pre-order, why I am telling it as a post order. There is a certain logic. What is the logic? You have already understood maybe. Here you can see where the root node position, in the root node position where it is. By seeing the root node, we are basically try to understand it's the in order, pre-order, or the post order. If it is in the middle, then it is called as a root node. If it is in the left side, then it is called as a pre-order. And if it is extreme right side, then it is called as a post order. That means we are doing the pre, we are doing the post, and if we visit middle, in the middle or in, then it is called as a in order, between, in. So that's why it is called as a in order. It's very simple. Now, next, this is a tree traversal, but what you can expect from here, that is in the exam. In the exam, basically, several questions are coming, and we will try to solve it by one. In some other videos, we will try to solve it by one. In this video, we will try to explain with one example, and from next to onwards, we will try to several example. We will do the several examples. Okay. Now, what kind of question you can expect? If that means I will give some kind of tree. Okay, I will give you some kind of tree, and according to this one, according to the given picture of the tree, you have to find the in order, you have to find the pre-order, and you have to find the post order. Okay, it's very simple. There are basically, you can't if you don't want to go with this kind of logic, it's very pretty okay. It's very simple. Okay, if you don't want to go with this kind of logic, then it's okay. I will give you another shortcut technique. By using the shortcut technique, you can solve any questions regarding the binary tree traversal. If any kind of question will come regarding the binary search, binary trees, then you can solve by you can find the in order, pre-order, in the post order within a second. Okay. Now let's take an example. if I have if I have a tree something like that, A, okay, then we have a B, okay, then we have a C, then we have a D, then after we have E, and we have F. Okay, if a tree is given something like that, then what is the pre-order, what is the post-order, and what is the in-order? You have to find it. Okay, it's very simple. So how you can do it? Let me change the color of the pen. That will be easier for you to understand. Okay, see, it's very simple, very simple. Okay, if you want to find the pre-order, if you want to find the pre-order, what you have to do, you have to make some kind of lines, or you have to draw some kind of line, the left hand side of every bubble, left hand side of every bubble, left hand side of every bubble. Okay, left hand side of every bubble, the first step. Understood? Okay, this one, left hand side of every bubble. Pre means root. Pre means this one. That means pre-order means in the left hand side. You have to remember it in that way. Pre means in the left hand side. Okay, in the left hand side you have to draw a single line uh, to the every node. Okay, the first step. Okay, completed the first step. Next step, what I'm going to do, let me check another, let me change another color. Okay, okay, now we will go to try to traverse it. Okay, now we will try to traverse from the A. Okay, and wherever we will get the intersection, we will write the order. Okay, what does it mean? That means I am going. Okay, it's intersect. That means in which node we intersect? A. That means we will write it as A. Okay, now we are going, go to the B, then after C. Okay, then means A, then B, and the C. And now where we will go? We will go to the B, then after D, intersect, then you write the D. Okay, now go, then intersect E, and then intersect F, E, and the F. Now you can tell the process ends here. No, you have to go to the A. As your all the you can think it in that way, that is all the nodes are visited, then why we will go to the A? No, it's a step, it's a clear, and it's a rule. You have to finish it to the A. If you have started it from the A, you have to finish it there. Okay, that means we will go. Any kind of intersection is basically doing no. Any kind of intersection is basically doing no. Any kind of intersection, no. I have to stop here, and this is my pre-order traversal, and this is my pre-order traversal. It's very simple. Okay, understood? Let's take another example. Let's take another example. With the help of the example, we will try to understand it. Okay, now A, B, C, then after D, then after F, then after E, and the G. Okay, A, B, B, D, D to F, G to E, A to C, and C to E. This is your given tree. Okay, now what is your objective? It's very simple. I want to find the pre-order. Okay, I want to find the pre-order. What will be the first step? You please tell. The first step is basically you have to draw a line of left hand side of every node. Draw it first. Draw it first. Otherwise, we can't find any kind of intersection. Draw it first. Draw it first. Okay, done. Next step, what you have to do? Let me change the pen color first. Okay, now start it from the A, and again you have to finish it in the A. Going. Okay, intersect. Going. Okay, intersect. Going, intersect, and the intersect. Now let me write it. Otherwise, I will forgot it. What will be the order? A, B, D, F. Now we will go to going. Now no, 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 no. Again intersect. Again intersect. Then C. Now go. Okay, intersect G. E and the G. Okay. Now I have to stop it here. Yes or no? No, I don't have to stop it here. As I have started it from the A, then I have to finish it to the A. Go. Any kind of intersection is basically doing no. Now stop it here. Now you can tell it this is the pre-order. This is the pre-order of this table of this graph. Okay. Now let's take another example. Okay. Now again another example. Let me change my pen color. Okay. Now you have a tree something like A. Then you have B. Then you have C. Then after you have D, then E, then you have F, then after you have G. Okay, D, F, E, C, A. Okay, what is my objective? My objective is very simple. I want to find the pre-order. I want to find the pre-order, right? Then what will be the pre-order? What is the first step? I have to draw a line to the left hand side of every bubble or every node you can tell. Okay, next step, I have to traverse it. Let me change the color first. Then start A intersect B intersect D intersect F intersect. Okay, let me write it first. A B D F. Now go. Now it's intersecting. No, it's not intersecting. Okay, if I have drawn it D and the E at the I have not given that much of space, but it's not intersecting. You have to understood why. Because because we are going up and upstairs. Okay, so B A C, then E, okay, then G, okay, then F, then after C, E, and the G. It is the pre-order traversal. Okay. Now, this is the final one, or you have to stop it here? No. As you have started it from the A, you have to finish it there. Done. This is the this is the final this is the final one of the pre-order. Okay. Is that clear? Now we will go to the in order, or you can go it to the post order. Okay. Now I will go to the in order. Okay. Now again I have to draw it, because in that image, if I explain it with the in order, then you are not able to understand. Okay, the same thing I will draw it, the same thing. Okay, for the in order. Now my objective is different. Now I want to find the in order. Okay, D, E, and the F. Okay, okay, this one, very simple. Now my question, I want to find in order. Okay, in order. We have done it with the pre-order. Now I want to do the in order. In the in order, what you have to do, you have to make a line just just uh, bottom of the bubble, but bottom of the every bubble, bottom of the every bubble, bottom of the every bubble. Okay, now the same process, the same process. Okay, now the same process. Now start it from the A. Okay, okay. Now intersect. B is intersecting. No. C intersect. B. intersect. Now write it. Let me write it because I have a problem to forgot all these things. A B, not the B, not the B. It's not the B. A C, then after B, and then we will go to the D. Intersect? No. E, yes, intersect. F, intersect. Then A, B, D intersecting A, C, B. D intersecting? No. E, F, and then after you have to go to the D, and you have to stop the process to the A. Okay, so F, then after have the D. So this one is the order of the in order. Very simple, very simple. Okay, now let's take another example. This one. Now let's take the another example. This one. Okay, now remove it. It will be easier for us. That will take the less time. That will take the less time. Okay, we have done it with the pre-order. Now my objective is I want to find the in order. Now I want to find the in order. Okay, pre-order we have done it. Now my objective is the in order. Okay, now what I have to do, I have to draw the straight line bottom of every bubble. 1 2 3 4 5 6 and the 7. Okay, now next job, let me change the color first. Now start it here. Intersecting? No. Intersecting? No. Intersecting D? No. Yes, D is intersecting. F is intersecting. Now B is intersecting. A is intersecting. Now let me write it down. D, F, B, A. Now C, yes, intersecting. E, no. G, yes. E. Okay. Then after D, F, A, then after we have C, then after we have G, and then after we have E. This is the final of the in order. It's the final one for the in order. Okay, now let's take another example. Okay, I have to erase all these things so that within the less period of time I can finish all these things, the important things. Okay, now what I have to do, I have to find the in order. Okay, now pre-order we have done it. Now in order, same thing. Try to draw one the bottom of every bubble. Okay, now let me change the color. I have to traverse it, starting it from the A, no. B, yes. D, no. F, yes. Then after D. Okay, then B, F, B, F, D. Then we have to go to the A, then C, A, then E, G, C. E, G, and the C. This is the in order. Okay, it's very simple, very simple. It's the in order. Okay, then next what I have to do, I have to do the post order. I have to do the post order. Okay, the same thing in the same example. I have to do the post order. Let me remove it first. Okay, post order. I want to find the post order. Okay, in the post order, what I have to do, just opposite to the pre-order. In the pre-order, we have drawn it in the left side, but now we have to draw it in the right side of every bubble. Okay, okay. Then next step, let me change the color and we have to traverse it. Start going. Okay, intersect, successfully intersect. D, E, successfully intersect, successfully intersect, 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 intersect. Now I have to stop it here. Okay. Now the first one will be C. Then after F, E, D, B, and the A. This is the post order. Now apply it for the second other two trees. Okay. Let me remove it first. Okay. Now post order. After seeing this one, you are not able to do a wrong solution. You can't find a wrong solution of this kind of questions. After seeing this one, I am giving the guarantee to you. Going, going, now intersect, going, intersect, intersect, and the process stop here. So the post order. Okay, in the post order, what I have to do? Mm, the first is basically F, D, B, G, E, C, and the A. This is the post order. Okay. Now let's take another example, the final one. Let me remove it first. After that, we'll try to draw the post order. Post order. Post order. Okay. Now for the post order, what I have to do? Draw it at the right hand side. Okay. Now start it from the left. Going. No. F, D, successfully intersect B. So F, D, B, then after C, E, G, okay, G, E, C, A, G, E, C, A. This is for the post order traversal. Thank you. In the next video, we will try to solve the another question. The question is basically related to the AVL trees.